Purpose. The purpose of this lab is to determine the unknown concentrations, the pH and pOH, of 3 different acids by titration.
Theory. Titration is a technique where a solution of known concentration is used to determine the concentration of an unknown solution. It is a common lab method of quantitative chemical analysis. In titration, the endpoint is the point that is indicated by a change in color by the indicator, while the equivalence is the point at which equivalent quantities of acid and base have been mixed. The indicator is the substance that indicates the point at which the reaction is complete, and in this lab was phenolphthalein.
Theory continued. The balanced neutralization equations for this lab are shown below. Safety. First, gloves were worn at all times to protect hands from substances.
Next, an apron was worn to protect clothes from substances.
Then, safety goggles were worn to protect eyes from substances.
Closed-toed shoes were worn to protect feet from any spilled substance.
Procedures.
First, 2 clean burettes were set up. One was used for base and the other was used for acid.
The acid burette was rinsed 3 times with the acid solution, and the base burette was rinsed 3 times with the base solution.
The acid burette was filled to the 0 milliliter mark, meaning there was 50 milliliters of acid added to the burette, and this was also done to the base burette.
12 milliliters of acid was released from the acid burette. The initial volume and final volumes were recorded. 3 drops of indicator, which was phenolphthalein, was added to the 12 milliliters of acid.
Base was added to the acid and swirled until the solution remained pink.
The volume of the base used was recorded.
This process was done for 3 different acids, 2 of which were hydrochloric and the last sulfuric acid.
Each time a new acid was used, the color of the tape switched. Data. For the average volume used, the 3 total volumes used for both the acid and base were added together, then divided by 3. For the average number of moles used, the equation molarity equals the number of moles over the liters of solution was used, then the numbers were plugged in to get the answer. For the average molarity, the same equation was used for the acid to get the answer, and for base, the molarity written on the base flask was used. For the average concentration of H3O+, the acid was the same as its molarity, and for base, the pOH was divided into the constant of water to get the answer. For average pH, the negative log was used with its average concentration of H3O+. For average concentration of OH negative, the acid was found using the constant of water and the base was its molarity. And for average pOH, the negative log was used with its average concentration of OH negative. Our results were compared with 4 other groups and were averaged.
Discussion. After comparing our results with Lily and Yen's group, we found that our group used less milliliters of base to turn the solution pink than their group. Again, for acid B, we found that our data was less as well. Although for acid C, our use of milliliters was greater than theirs.
Some possible errors include putting in too much acid or base into the flask, not using enough, not cleaning out the burettes well enough, and incorrectly calculating the math after the data was collected.